Welcome children. Good morning everybody. Now we are in the last session about our 9th class physical science first lesson, matter around us. In the last two sessions it was about what is matter, what are the states of matter, how does matter changes its shape, and other characteristics like volume, pressure, those things were discussed. And we also discussed the special characteristics like compressibility, diffusion, and in daily life situations where we see compressibility and diffusion also. We also came to a conclusion that solids, liquids and gases, they all diffuse into liquids. These are all the matters that were discussed so far. Now here we are going to see the lab activity. It is about diffusion of two gases. See, we did not talk about how two gases diffuse each other. Here is the lab activity. For that, a special tube made of glass is taken. It's of length around 1 meter. And first process is that we should evacuate the tube. Evacuation in the sense that removing all the gases from the tube. Because any gases if remaining in the tube, it makes the process disturbed. Okay. It's as simple as that. Whenever we are going to drink something or eat something in a plate, first we clean up all the things. In the same way, we remove all the gases from this glass tube. Then we take two chemicals. They are hydrochloric acid HCl and ammonia NH3. One important thing is that basically HCl is a gas and ammonia is also a gas. Now we take two cotton balls and we dip in HCl solution and ammonia solution. How can we prepare their solutions? Just making these two gases diffusing into water. Okay, because we cannot dip cotton balls in the gases. It's needed to make solutions. So we prepare solution of HCl by diffusing HCl gas into water, and in the same way we'll prepare ammonia solution as well. Okay, now take two cotton balls, dip one in the solution of HCl, the other in the solution of ammonia. After dipping them, place the two cotton balls at two ends of the tube. It has two open ends. One end, say at the left side, we kept the cotton ball dipped in HCl. At the right end, we kept the cotton ball dipped in ammonia solution. Right? Now just wait and see what happens. Just after a few minutes, the reaction takes place between HCl and NH3 and they form a compound called NH4Cl. It's called ammonium chloride. How can we say that this is formed? See, whenever any chemical reaction completes, there will be an evidence of smell change, color change, something. Here, as an evidence for this reaction completion and ammonium chloride formation, we get this part which is white dense ring, dense in the sense thick ring. Ammonium chloride forms fumes, smoke of dense white color. So, this white color thick ring confirms the reaction is completed between HCl and NH3 and it formed ammonium chloride. That is point number 1. So, we can conclude that gases both diffused together. Diffusion of two gases has taken place. That is conclusion number 1. Second conclusion is that when you observe the position of this ring, it's not exactly in the middle. It is close to HCl and it is far from ammonia. Why it is happened so that? The reason is that when you calculate the molecular weight of HCl, it comes 36.5 gram because hydrogen weight is 1, chlorine weight is 35.5. Altogether it is 36.5 gram. Next, ammonia weight is 1, nitrogen 14 gram, 3 hydrogen 3 gram. So it is 17 gram. Just compare the two weights. Ammonia is lighter, so that it runs faster. That is why ammonia gas traveled more distance as compared to HCl gas. That is why the ring is also formed far from ammonia and close to HCl. So the conclusion from this observation of the position is that lighter gases diffuse faster. Right? So by this lab activity we got two conclusions. One is that two gases diffuse and the other is that lighter gases diffuse faster. Okay, look at this figure and just come to a confirmation of both the results. Is it fine? Okay, now we discuss how small the particles of matter are. You know, the molecules of matter, sometimes they will be of the size which is invisible to the naked eye. That means like molecules of ice cream, we cannot see them directly. The size will be so small. How to confirm that? Simple. You have an activity 7 in the textbook. Take some like 100 ml of water, add some potassium permanganate. When you look at potassium permanganate initially, it looks like black color like iron fillings. When you add a pinch of potassium permanganate to water, it turns into dark pink color. Right? Pink color confirms potassium permanganate diffused into water. It is dissolved into water. Fine? One pot is over. Next, in another beaker, take 100 ml normal plain water. From this previous one, take 5 to 10 ml of mixed water. Mixed in the sense, water plus potassium permanganate. Add this to this water, 100 ml plain water. This water also will be converted into pink color. One more 100 ml of water you take, then add this one. That is also converted. So you go on repeating this one, it will be keeping on changing the color. But the difference is that whenever you are going for further addition of water again and again, the brightness, the thickness of the color will be decreased. Okay? Right? It confirms that the molecules are so small that they can going on diffusing into even more quantity of water or some other solvent added. Right? Another activity, there exists space between the particles. See, when you add sugar to milk, we cannot see sugar separately. You know, dissolving of sugar into milk is nothing but there are little gaps between the molecules of milk. Liquids will have little gaps? No. So whenever we stir sugar, that shows that sugar particles are occupying the gaps between milk molecules. Here it is given in the activity 8 to add water and salt. All the salt particles will diffuse into water. They occupy the gaps. Okay, just go on adding like this. They will be going on diffusing. So that confirms that there exists space. How to confirm? Because after adding salt to water also, there will be hardly no rise in the water level. Why the water level is not rising? Because there are already gaps between the water molecules and these salt particles are occupying that space, so that there is no increase in the water level. Right? So by the two activities we can say that there are gaps between the molecules in matter and molecules are very tiny, in the sense very small. And coming to another activity, particles of matter attract each other. It's very simple. Whenever you turn on a tap, water will be flowing down like a stream. You know, all the water molecules are attached to one another. How can you confirm that they are attached? Keep your finger in the middle of the water flow. Just they flow through your finger and they will go as usual from the bottom of your finger again. If there is no attachment, water should cut and it should separate, but it's not happening. That confirms that there is force of attraction between molecules of matter, so that the stream continues going on the same way as it had started at the beginning of the tap. Okay, now coming to the last topic of the lesson, diffusion takes place from solids, liquids and gases into liquids and gases. Already we have seen that for solids, liquids, gases, diffusing into liquids, and it also diffuses into gases, like incense stick, agarbatti we call, camphor smell, scent smell, water and salt, sugar and milk. So many things like soda water, I said, carbon dioxide dissolved into water. So many examples will confirm that diffusion takes place from solids, liquids and gases into liquids and gases. But the most important point here is that the rate of diffusion, that means how fast it is diffusing, depends upon the space between the particles. That means if there is enough space, like gases which have huge gaps, there will be more diffusion probability compared to liquids. And liquids diffusion rate will be more as compared to solids, because solid molecules are packed. So when you write the order of rate of diffusion, it's gases who have the highest rate of diffusion, next comes the liquid, and then comes the solids. Okay, it's just because of the gap that the molecules have. So in the entire chapter of matter around us, it's about matter is made up of molecules. They have gaps between them. They have force of attraction between them. They are very tiny. They show the properties of pressure, volume, and they respond to different situations. Diffusion takes place, compressibility takes place, and diffusion takes place between different states of matter altogether. Okay, so study the textbook from activity 7 onwards, and the questions will be given, and the following the answers will also be given. Just follow the questions, read lab activity very carefully. And as you know, during this pandemic situation, stay home, stay safe. In the next session, we will be dealing with a new lesson. Till then, complete all the things that are listed here. Thank you very much.